Assalamualaikum. My name is NURUL HAZWANI BINTI ZAHID from CS1104A.
I will introduce the chapter 4, which is directed graph. My group will cover the topic 4.1 graph and topic 4.2 relation, function and directed graph. In the previous chapter, a relation is represented by listing the order pairs. However, in this case, it is more convenient to use a picture, or also known as a graph. Directed graphs are frequently useful in various dynamic systems such as digital computers or flow systems. This chapter gives the basic definition and properties of directed graph. For the first question, give an example of subgraph of G which consists of 5 vertices of G. In the question, it has 5 vertices, so we put A, B, C, D, and E just like in the question. What is subgraph? For your information, subgraph is a graph whose vertices and edges are subset of another graph. In general, a subgraph need not have all possible edges. I will start with the B. First, B go to the A, and after that, A go to the C, C go to E, and then we go to B to the D, and then D to the E, and we got the answer for this question.
So now let's take a look at the second question. The second question is determine the degree, in degree, and out degree of each vertex. So take a look at the directed graph from figure 1 and make a table like this. The table is vertex, in degree, out degree, and degree. In vertex table, we need to put A, B, C, D, and E just like in figure 1. So let's take a look at the in degree table. In degree is what we receive from another vertex. So the vertex A only one that it received. So we put 1 in degree for vertex A. For vertex B, there is no that it received from another vertex. So we put 0. For C, there is same with A. So we put 1. For D, it received 3 from another vertex. So we put 3. And lastly, we put 2 in vertex E. For out degree, we send another to another vertex. So in vertex A, we send 2 to another vertex. For B, we also send to another vertex. And C also 2. For D, we send only 1, so put 1. And E, there is no it sent to another vertex, so we put 0. And lastly, in degree table, we calculate all in degree and out degree, so we got 3 for vertex A, 2 for vertex B. For vertex C, we got 3 for degree, and vertex D, we got 4 for degree, and lastly, we got 2 for vertex E. You got the answer for the question 2. So next, for the question 3.
For question 3, state the shortest length from node A to node E. Let's take a look at the directed graph from figure 1. Take your time to figure it out what the answer of this question. Okay, so I will show you how to get the answer. Take a look from node A and we go to node C and go to node E, and we got 2 lengths from them. After that, take a look again from node A to node D and to node E. Also, we got 2 lengths. And lastly, we take a look from node A to node C to node D and lastly to node E, and we got 3 lengths. So the last answer for this question is 2 for the length.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IMRAN bin IBRAHIM and I will explain for the question March 2050. For the next question, March 2050, given the relation F173751788385. For the question 1 is draw the director graph for the relation F. We will solve this question first. The first step you need to do is draw all the nodes in the relation F. The node is 1, 7, 8, 5, 3. How do you want to know all the nodes you need to draw? In relation F, there is 1, so you need to draw 1, 7, draw 7, 3, 3, 8, and 5. For the next step is you need to draw the edges such as 1 to 7, 3 goes to 7, 5 goes to 1, 7 goes to 8, 8 goes to 3, and 8 goes to 5. This is the answer and the final graph of this question. So we move to another question. State the domain and range of the function. Before that, we need to know what is domain and range. The definition of domain and range is for the function of f, a, b, a is called the domain of f and b is codomain of f. The set of image under f is the range of f. The domain is 4, 1, and 7. The domain is 1, 3, 7. The domain is 3, 5, 1. The domain is 5, 8, 3. The domain is 8, and 8, 5. The domain is 8. So the domain is 1, 3, 5, 7, and 8. The range is 7, 1, 8, 3, 5. Before you answer this question, this is definition of domain, codomain, and range that you need to know in order to you solve this question. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. My name is Muhammad FAHMI bin RAMZI and I'm from class CS1104A and I'm going to present a chapter Fundamental of Logic that consists of topic 5.1 Basic Connectives and Truth Tables and 5.2 Logical Equivalence. This introduction of Chapter 5 is logic is the action of reasoning. We use logic in our everyday lives. We determine whether a statement is true or false. We use logic to deduce the conclusion of an agreement. We use logical rule for control system to define how they should operate. In this chapter, we will look at the basic in the algebra of propositions. I am going to explain the example from the past year question of December 2019, question 5a. The question asks us to construct a truth table to determine whether the following expressions are logical equivalent or not. If P then Q, and if not Q then not are equivalent to if P or R then Q. So in this question, we have P, Q, and R. How to decide how many rows we have in our truth table? 2 power of how many words we have. So in my question, we have 3, so it has 2 power of 3. it is 8. So we have 8 rows in our column. The first column divided by 2 and we got 4. So we put 4 true and 4 false. As you can see, I put 4 true and 4 false. We are trying to get the possible combination for the truth table. So for the second column, now divide 4 by 2. So we got true, true, false, false, and so on, true, true, and false, false. Repeat the same process for R, and we got true, false, true, false, true, false, and true, false. So now we have negation of Q. Basically, everything in the Q column right now is not opposition for negation of Q. So in the column Q, it is true, so not Q is false. It is true and false. If it is false, then it's true. It's false, true. It's true, false. It is true, false. It is false, true, and it's false, true. It's the same to not R. So R is true, then it's false. If R is false, it's true. If R is true, it's false, and so on. So next, look at where the implication we're pointing to. If that is true, then it doesn't matter the other side say it's always going to be true. If we have false and true, so the answer is false. If we have false and false, it's going to be true. And if we have true and true, it's going to be true. Right now, if P then Q, so it's pointing to Q. So whatever Q is true, then it's true. So Q is true, it's true. Q is true, it's true. If Q is false, then we need to check to P. If P is true but Q is false, then false. But if Q is false and P is false, then it's going to be true. So now the same technique as before is pointing to not R. So not R, false, and then if not Q is false, it's true. And if not R is true, it's true. And if not R is false, check the not Q and it's false. If not R is true, then it's true. If not R is false and not Q is false, then it's true. So now I have labeled 1 and 2 for this purpose, so that we can refer it easily from previous column. This is conjunction symbol, translated as and. If one of them is false, it's going to be false. So this, we can refer it to 1 and 2. So both is true, then true, true, true is true, false, false is false, then one of them is false, then it's going to be false. True, true is true, true, true is true, true, false is false, true, true is true. So next, this is the symbol of disjunction, or we translate it as OR. So if one another is true, then it's going to be true. So P O R is true, true is going to be true. True, false, so this is true, is going to be true. True, true is true, true, false is true, false, true is true, false, false is false. So false, true is true, false, false is false. So for the next one is, this one is implication to Q. So whatever is in Q is true, is going to be true. So Q is true, is true. Q is true, is true. So Q, if Q is false, then we look at this one. P or R is true, so it's going to be false. So and so on. So the conclusion of this question is to find whether it is logical equivalent or not. So basically, statement A and B need to be the same to be logically equivalent. As you can see, statement A and statement B need to be the same outcome. So it's true, 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 false, 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 true, 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 false, false, true, true. So it's actually a logically equivalence. So the final conclusion, since if P then Q and if not Q then not R is logically equivalent to if P or R then Q, therefore if P then Q and if not Q then R equivalent to if P or R then Q.
Assalamualaikum warahmatullahi wabarakatuh. My name is SYARAFUDDEEN bin IHSANULHADI and iPhone
March 2015, question 5. Okay, the question asked they asked by using the truth table, determine whether if P or Q then R logically implies if P then Q and if Q then R. Okay, next. First, we have P, Q, and R. So to decide how many rows that we have to produce, we have to calculate 2 power of how many alphabet that we have. For the question, we have 3. Then it will be 2 power of 3. Then we get 8, and we have 8 rows. For the first column, we have to divide the row by 2, and we got 4 for each 2 and 4. For the second row, we have to divide the row by 4, and we get 2 for each 2 and 4. For the third row, we have to divide the row by 8, and we get 1 for each 2 and 4. For the statement with P or Q, for all the statement P or Q is 2 is one of the order or both of the statement P and Q are 2. Okay, we proceed with the if P or Q then R. For if then statement, the truth value of P or Q then R is false only when the hypothesis P or Q is true and the conclusion R is false. Okay, next. Then we move on to if P then Q and if Q then R. Next, we combine if P then Q and if Q then R for the for an statement. The statement is true if both of the primitive statement is true. If either the primitive statement is false, then it will be false. Okay. Then we can see is P or Q then R. With if P then Q and if Q then R have the same answer in the final column. Okay, next. Since if P or Q then R, if and only if P then Q and if Q then R is contingent, therefore if P or Q then R logically implies if P then Q and if Q then R. Okay, thank you. That's all from me. Thank you very much.